Hello guys and welcome. I hope that you're doing well. My name is UHDking or I play 4K, AK, I play 8K, AK, I play 16K, and during this video I'm going to demonstrate Diablo 3 PC game running in 8K UHD video resolution on two Titan RTX video cards in SLI. So two-way Nvidia SLI will be demonstrated, or the last dinosaur, the last mammoth of the SLI technology, such as Nvidia Turing GPU architecture in form of Titan RTX video cards, two of them, which is pretty much king of the or flagship of the RTX 2000 series Nvidia video cards or RTX 20 series Nvidia video cards, a little bit faster than RTX 2080 Ti video card, and each Titan RTX is equipped with 24 GB of video RAM GDR6, while RTX 2080 Ti video card is equipped with only 11 GB of video RAM. At the left top corner, the display information system updated every single second, verified every single data is what it is. By the end of this video, I'm going to demonstrate the computer specifications and some more details. Okay, so let's go ahead and have a look at the presets. Throughout this video, I'm going to demonstrate all kind of different presets, for the maximum visual preset all the way to the lowest. Okay, keep in mind that I'm also recorded 16K UHD video resolution in Diablo III PC game on two Titan RTX video cards in SLI, and it is available over the UHDking.com. Go ahead and check it out. It's going to be amazing video. Pretty much the result will be 132.7 megapixels, or exactly 4 8K screens, as I'm today demonstrating, but 4 times of those screens stitched together into 16K UHD native resolution. Alright, so I'm gonna put in the video comments that link for you to check out, as well as I'm going to put in video links single Titan RTX video card in i9-9900K overclock at 5.2 gigahertz, the same CPU that I'm using today, Intel 9 Gen. But only 8 physical cores. Hyper-threading technology is disabled. 8 physical cores more than enough in 8K video resolution in Diablo 3 PC game. Intel Gen 9 flagship CPU as well. So pretty much technologies will be from 2018, including the Titan RTX video cards and SLI, but it was the flagship in 2018, and it's still whooping some ass in 2023. And 8K video resolution, absolutely comfortable gaming experience, and the first video cards such as Titan RTX video card in two-way SLI by the Nvidia is capable to push playable experience in Diablo 3 PC game, not just benchable experience under 16K video resolution, but playable. But today we're going to play 8K UHD, which is 7680 by 4320. I'm going to start with the anti-aliasing EVGA, okay, and we're gonna then turn it down. Maximum possible visual presets, as you can see over here. This is how we're gonna go ahead and rock, and then I'm going to lower it down. Reflection is on. Let's go ahead and have a look, guys. As again, in the end of this video, I'm going to demonstrate how I set up the SLI profile. It's going to be custom SLI profile, but under the Nvidia drivers without any Nvidia Inspector. Easy stuff to do. It's going to be part of my SLIready.com or SLIreadygames.com YouTube channel, which will be dedicated to the SLI profiles, to the multiple Nvidia video cards, and how to enable multiple Nvidia video cards such as Nvidia SLI technology in the games under DirectX 9, DirectX 10, and DirectX 11 APIs. Due to DirectX 12 API doesn't support SLI, but it does support multiple GPUs, but it's not the SLI. Alright, so let's go ahead and have a look, guys. So this is how we're going to go ahead and do it. So as again, this is not about the gameplay, it's going to be about the benchmarking. But this video will provide a multiple value no matter what kind of industry you're coming from. If you're a PC gamer, PC hardware enthusiast, PC overclocker, 3D artist, graphics designer, or just computer scientist, it's going to be a great video for you to watch. Alright, so as you can see, I started 8K UHD, maximum possible visuals, including the anti-aliasing EVGA, and FPS is above 80 FPS. Keep in mind, just today I'm recording with Nvidia ShadowPlay, and you gotta add solid 3 FPS to the FPS counter while I'm not recording. Even a little bit more than that. It's 5 FPS. Under this 16K UHD it was 3 FPS because pretty much it's like 8-10%. So go ahead and add solid, I would say solid 5 FPS to the FPS counter if I'm not recording on the same computer with Nvidia ShadowPlay. But right now I'm recording on the same computer with Nvidia ShadowPlay in real time, but I'm recording it under the 8K UHD video resolution due that my Nvidia ShadowPlay and Nvidia driver is hacked. But you don't need to hack your Nvidia driver if you're trying to play 8K UHD. I hack it to play 16K UHD, and under my 16K UHD video resolution gameplay of the Diablo III PC game, I explain exactly why. So go ahead and check it out in video comments down below. This is going to be a single take. I'm coming in real time, guys. I'm not going to edit this video, and my voice can be distorted a little bit. Due that I'm using the artificial intelligence that's removing some noise out of my voice because I'm sitting by the open case and two Titan RTXs with the Founders Edition dual fan design, and each is kind of noisy at 100% fan rotation. As you can see at the left top corner, fan rotation 100% per video card. As you can see, I'm playing the Prime Evil Collection Edition, which includes all the DLCs for Diablo 3, including the Diablo II Resurrection PC game, and I'm going to demonstrate Diablo II Resurrection PC game as well throughout my video. Please keep that in mind. And it's going to be available over the UHDking.com. I'm also going to demonstrate in Diablo 3 all kind of different resolutions: 4K resolution, 5K video resolution, 6K video resolution, all kind of different 6K video resolution, 7K video resolution, 8K video resolution, 10K video resolution, 12K video resolution, as again all kind of different 12K video resolution, such as 12K UHD, 12K 8K screen stitched together in vertical mode. It's going to be a nice, great videos to watch, and I'm going to include the video links to those videos in the video comments, so go ahead and check it out, guys. Don't forget to smash the like button because I'm running on my own pocket and on my own time. A lot of time, mining energy is invested, and nobody sponsored me to that. But it's going to be a great video for you to watch, especially if you're a Diablo fan. Go ahead and smash that like button, subscribe, and share it with your friends. As you can see, I'm starting with a beautiful wings, beautiful flag, and the pet, kind of the skeleton guy running with me. It's kind of useless, but it came with the Prime Evil Collection Edition that pretty much, as again, including all the Diablo 3 DLCs, all additional stories, extra bonuses, including including the Diablo 2 Resurrection. And Diablo 2 Resurrection even has a much better visuals, guys, graphics than Diablo 3. And Diablo 2 Resurrection is such a deal, guys. Right now it's running, the whole set running $19, 20 bucks. It's like it's supposed to be at least $60 for two of those games, Diablo 3 and Diablo 2 Resurrection, as minimum, but usually it's running like $60 for the Diablo 3 with all the bonuses and DLCs, and the $40 for the Diablo 2 Resurrection. But on May 24th, 2023, on June 24th, 2023, today is June 24th, 2023, they running on the bell.net, they're running a big discount on their games, and guys, such a deal. So I pick it up for you. Don't forget to smash that like button, sponsor me, watch my videos, and maybe I'm gonna give some games giveaways as well on the bellnet.com, maybe a couple of Diablos, but I'm looking for your support, guys. Please watch my sponsors, smash that like button and support me. So maximum visuals running beautiful, guys, 75-82 fps, but without the recording it's like around 82-85 fps. That's a great result, especially when we are talking multi-sampling 8x, anti-aliasing 8x, and as you can see, almost perfect SLI scalability, but still I'm bottlenecking through my Intel 9th Gen CPU, which is 9900K. Even when it's overclocked from 3.6 to 5.2 gigahertz, it's not enough instruction per clock to be able to push two Titan RTX video cards. I had no problem with two RTX 2080 Ti video cards in SLI, but two Titan RTX video cards in SLI, 512 CUDA core more as summary over two RTX 2080 Ti video cards, and Intel Gen 9 cannot fully utilize at 97% per each video card. But secondary video card is utilized at 97, 99%, but first one is struggling, it's like 92, 93. Okay, if I'm going to remove the anti-aliasing, make it none completely, so you can assume how much will be 4x in between, the utilization will be even worse than that. Keep that in mind. And if you play in Diablo III PC game with the video cards such as Turing GPU architecture RTX 2080 Ti or Titan RTX video cards in SLI, two of those, you want to make sure, guys, that you're running at least 8K video resolution, so every single video card will be utilized over 90%. That means that you're gonna waste about 8% of your CUDA cores during CUDA cores by Nvidia. They're idling, they're wasted. And while we're talking about the GPUs, about the video cards, you want to utilize every single CUDA core at 97 at least percent, but the best way will be 99-100%. But as again, Intel Gen 9, which is pretty much the last CPU that is capable to run certified SLI. Based on a chipset on the motherboards, because the last one will be Intel 11 Gen, but while my Intel Gen 9 overclock, it's faster than Intel Gen 10 in terms of instruction per clock of the external frequencies, while Intel Gen 10 running stock, and Intel Gen 10 and Intel Gen 11, actually Intel Gen 11, which is the Z490 motherboard, is the last motherboard that supports SLI, Nvidia SLI, which means multiple video cards certified by Nvidia, integrated into the chipset and into the PCI Express Gen 3 slots. Keep that in mind. And today I'm running the Intel Z390 chipset motherboard. It's ASUS Z390 Maximus Hera, and it's certified a Gen 3 PCI Express slots running at 8x per slot. I do that CPU Intel Gen 9 9900K is limited to only 24 lanes on the PCI Express Gen 3, and 2 times 8 it's 16x, and then I can install one more third slot Gen 3, which is 4x, so it's going to be from 16 to 4, it's going to be 20x, right? And then 4x will be dedicated for M.2 SSD storage device, okay, integrated. If you would like to integrate it into the motherboard, this is what it is, and it's not supported above 24 lanes. So pretty much there's no way what you can do in terms of the native chipset Z390. It's always will be utilized with 24 lanes on the PCI Express Gen 3. So this is how it's designed, and you can run the server boards, or you can run the desktop Intel CPUs, which will be slower than Intel 9 Gen CPUs, like 98XE CPU, and you can have full Gen 3 PCI Express slots, two of them running each 16x, but there is, guys, not such a difference. Even when you're running at 8K video resolution, the difference will be like 1%. Keep that in mind in certain games, not all of the games. Keep that in mind. Maybe under 16K video resolution in a lot of games you're going to be like 1% of the advantage, but not that much, because I tested, and trust me, it's not that much. It's maybe limited just to 1 or 2% of the game, but usually the performance will be the same, because PCI Express Gen 3 slots are more than enough for Turing GPU architecture flagship video cards running SLI, Nvidia SLI, while rendering your favorite games. Keep that in mind. As again, SLI technology by Nvidia supported under DirectX 9, DirectX 10, and DirectX 11 APIs. Also can be integrated in Vulkan APIs and OpenGL APIs, but does not support it under DirectX 12 API. But DirectX 12 API by Microsoft supporting multiple GPUs. It has integrated classes, but developers so lazy they're not even utilizing it, and it's easy to use it, but they're not utilizing it. So Nvidia decided not to support DirectX 12 API, so it's no longer supporting under DirectX 12 API, SLI, because they decided what's the point if DirectX Follow API already comes with the solid multiple GPU support, but developers are not utilizing. So Nvidia decided, you know what, developers are not utilizing it anyways, why are we supposed to waste our time? Which is not a great decision by Nvidia, but it is what it is. So pretty much this is the last dinosaur, the last mammoth that's supporting fully Nvidia SLI technology in PC games, such as Turing GPU architecture. The latest video card will be RTX 3090 Ti video card that's supporting SLI. But as again, it will be actually 2 times faster than two Titan RTX video cards in SLI, and we are going to test it in the future. Keep that in mind, but only in the games DirectX 9, DirectX 10, and DirectX 11 API. It's also fully supported. So the Titan RTX video card is not last dinosaur. It's the latest, almost one of the last dinosaurs. But RTX 3090 Ti is the last actually dinosaur based on Nvidia Ampere GPU architecture. Nvidia EVGA GPU architecture doesn't support SLI as the gaming video card. It's supporting SLI, supporting mostly multiple GPUs, just like Nvidia Quadra GPUs, but not like just like Titan V as Titan Volta GPU architecture that didn't support SLI as gaming video card. It was full support like multiple GPUs like on Quadra, so it was struggling, alright? But Titan X as Maxwell GPU architecture, Titan X as Pascal GPU architecture, Titan RTX as Turing GPU architecture, and RTX 3090 Ti as a flagship of the Nvidia Ampere GPU architecture supporting SLI. And but as again, you're not gonna find a motherboard that's going to fully gaming motherboard with a gaming chipset for the Intel that's going to fully utilize the SLI technology for the RTX 3090 Ti video cards fully, because as you can see, Intel 9 Gen CPU cannot utilize Turing GPU architecture. And keep in mind that Nvidia Ampere GPU architecture such as RTX 3090 Ti is actually 2 times faster than single Titan RTX if your CPU is capable utilize fully GPU at 99%. So two of those will be 4 times faster as Titan RTX. It will be as fast as RTX 4090 video card single, and it's kind of hard to find the gaming chipset that supports certified SLI through a chipset on the motherboard and gaming CPU that will be utilizing the full potential of the two RTX 3090 Ti. So technically we can say that this is the best scenario for the SLI technology, because the Ampere GPU architecture, maybe you can utilize it on some server motherboards with the multiple core CPUs, but usually those CPUs are low on frequencies, and maybe in 2025 year they're going to be having such a frequency that will dominate that CPU at any point of time, because usually those CPUs running like 32 cores and they're kind of running 3 gigahertz frequency, 3.5 gigahertz frequency, and kind of cannot go overclock above 4.5 gigahertz, and it's going to be even slower. Right now those CPUs in 2023 by AMD or Intel going to be slower even than this Intel Gen 9 at 5.2 gigahertz. But in 2025 there is a possibility it's going to be chipset from AMD or Intel that will be utilizing still PCI Express Gen 3 at 16x, no problem. Two of those slots fully at 16x, and it's going to be faster than this Gen 9 CPU, maybe in 2025 with like 32 cores or 36 cores, Intel or AMD, but not at this moment in 2023. And then you can achieve additional, I would say 10-15% while your Titan RTXs will be running stock, or maybe even utilize fully RTX 3090 Ti video cards. All right, so I showed you guys the FPS, right? So this was completely maxed out but without the anti-aliasing. So the next thing what we can do, we can turn on the SSAO and this type of taxing a lot on Turing GPU architecture as well in terms of the FPS, about 10%. So we're gonna boost in about by 10% higher than it is. So let's go ahead and have a look. As again, AI, artificial intelligence, is removing the noise out of my voice because I'm coming in real time, sitting by the open case computer case, and two Titan RTXs, dual fan design on each, running 100%, kind of noisy, guys. When two of them running, it's kind of noisy. It's like single Titan X Maxwell running 100% single fan, designed by Nvidia, and it's kind of noisy, if you know what I mean. But look at this, 160 FPS, 140 FPS. It's running completely comfortable gameplay experience at 8K video resolution. The MS by the FPS at the left top corner, it's a latency delay in terms of milliseconds. So before every single frame is rendered, it's like 6 milliseconds, below 10 milliseconds. When your latency delay in terms of the milliseconds below 10 milliseconds, that means, guys, there is a stuttering free. Keep that in mind. It doesn't stutter at all. Right now I'm a little bit recording, so it might a little bit of stuttering because I'm recording in real time on the same computer. Keep that in mind. And as again, it takes like 5 FPS. But look at this, it's beautiful, 160 FPS, this is unbelievable, and this is maximum visuals without the SSIO, but there is hard to tell the difference without the SSIO or within the SSIO. Let me go ahead and zoom in to show you for those naysayers that yes, indeed, I'm running 8K UHD natively, and I'm going to use the Windows Microsoft Magnifier Zoom tool, and 400% under 8K HD, it's going to be 32K video resolution. Look, everything is so sharp. This is maximum possible visual. So this is under 8K UG rendered, and then zoom in into it by 400%. Everything is still so sharp, but I can see some edges on the 3D models require some anti-aliasing method, as you can see right there. Right now I'm running without the anti-aliasing, but this is 32K. Zoom in to 32K, can upscale from 8K UHD natively upscale to 32K. But let's go ahead and have a look at 16K UHD upscale from 8K UHD. Look at this, and now I barely can see that edges of the models require some anti-aliasing. Required some anti-aliasing. I'm not sure if YouTube is going to re-encode it and blur it out for you, but I can see it still requires some anti-aliasing while I'm running maximum visuals on 8K UHD and doing the zoom 200% to it, but not running any anti-aliasing. I can see that you still need the anti-aliasing under the 85-inch TV screen. Keep that in mind. But as again, if you're gonna bring all the way to 100%, you don't see any aliasing on 3D models meshes at all. It's just beautiful. And right now this model is about like what, 750 pixels by 250 pixels. So even if this texture is 1K resolution, such as 1024 pixels by 1024 pixels, we're still under 8K UHD, not fully rendering the full texture on that model. So under 16K video resolution, 16K UHD, as again I attached the video link to that benchmark, we're going to fully utilize the texture if it's going to be 1024 pixels by 1024 pixels. But if it's going to be 2048 pixels by 2048 pixels on this character and on the enemy characters, even under 16K UHD, we're not going to render the full amount of pixels. That's why it's not, you just scaling the textures, you just scaling the textures. No, I'm not. This is the real deal, and the visuals quality is unbelievable. You better check it out, even under 8K UHD natively. But when I'm running 8K, 16K UHD natively video resolution and downscale to 8K UHD, I can see a big difference versus the 8K native to 8K native, guys. It's just unbelievable how beautiful it is because every single pixel is rendered. Alright, so maximum visuals without SSIO, we saw the performance. Let me go ahead and lower it down. So I'm going to turn down now the reflection, and I'm going to lower it down. So I'm not going to go to medium, I'm just going to go to low, but not completely low, but kind of to low. And you can assume what will be performance if you're going to jump to medium, because it's going to be in between the performance difference. And you're going to see that artificially it's going to limit some pixel density in our textures right now. And shadows also is very horrible at low, so you better run shadows at medium and it's going to be nice, especially when we're talking 16K UHD. Shadows at medium is going to look like shadow at high under the 4K UHD for sure. Look at that beautiful FPS, 160 FPS average. This is unbelievable. Latency delay below 10 milliseconds for sure, and it's running so smooth. This is just unbelievable, guys. and video RAM utilization is so low, guys. As again, I got myself the Diablo 3 Prime Evil Collection edition, and it's including the Diablo 2 Resurrection, and that game is on another level from the Diablo 2 from Diablo 3 in terms of the visuals, because I believe it's running the newer game engine, much higher topology of triangles into 3D meshes, much higher texture quality. It's just mind-blowing under 8K video resolution. And as again, I'm going to record Diablo 2 Resurrected PC game under the UHDking for you to check out. And as you can see, it's sipping a little bit because I need to replace the battery into my mouse device. That's why it doesn't do it because it's stuttering. It's just doing it because my battery on my remote mouse is kind of running low. That's why it is. I'm losing. It's kind of under red status. I gotta replace it. Beautiful visuals, beautiful average FPS. This is just unbelievable. Just have a look. 160 FPS. This is just unbelievable, guys. And video RAM utilization below 6 megabytes. So SLI is fully ready for the Diablo 3 PC game, and let me show you how to set the custom profile. But pretty much you just learned the whole deal right here. It's beautiful, and you're going to have fun, especially if you're going to have a little bit lower performance video cards, not the Turing flagship, but let's say RTX 2080 Ti can be fully utilized with Gen 9 Intel CPU 9900K, and you're going to utilize RTX 2080 Ti video card 1 and video card 2, both of them at 97%, 99%, but look like two Titan RTXs video cards is additional Nvidia Turing 512 CUDA cores and Intel Gen 9 9900K flagship CPU doesn't have enough instruction per clock. It's bottlenecking through it to utilize over 8,000 solid over. I would say it's a solid actually 9200 CUDA cores. It just cannot do that. But below 9000 CUDA cores, it has no problem in terms of the Turing CUDA cores by Nvidia while running Intel Gen 9. Alright, so I showed you that. Let me go ahead and shut it down, guys, and let me introduce you to my system real quick. So as you can see, Titan RTX was running completely stock. Let me zoom in. As you can see, I'm using that Windows magnifier zoom tool. Is very handy, especially when you're running 8K video resolution and especially above. So 100% fan rotation video card synchronized, but there wasn't overclock through the MSI Afterburner running completely stock. The visuals on the Nvidia driver was set to quality. Of course, SLI, this is for those naysayers to video cards, maximum 3D performance. Under the manage 3D settings, let me show you, this is very important for those people who's trying to run multiple NVIDIA video cards. I'm going to show you how to set the custom profile. So under the main profile, I set it like this. Go ahead and smash the pause button and exactly duplicate what I'm having here. As again, I didn't use any NVIDIA Inspector. Keep that in mind. So as you can see over here, I'm not running the SR, it's completely 8K native. So maximum frame rate set to 1000 FPS just in case. So it's going to demonstrate the maximum FPS, and it will try to utilize every single NVIDIA Turing CUDA cores in our case. Maximum performance, very crucial as well. Instead of optimal or adaptive, set to maximum performance. And under SLI rendering mode over here, I'm running single GPU. But then I went to program settings, smash that add button. I found where I installed the Diablo 3 PC game. It's bal.net version. Click add, select that Diablo 3 executable file, and then add it, and then let's pull up some settings for it. And over here, what I did make sure that my power management mode set to prefer maximum performance, and under SLI rendering mode it was saying Nvidia SLI recommended. Do not use that because Nvidia driver doesn't have Diablo 3 SLI profile at all. Okay, never had it. So what you want to do, you want to click force alternative frame rendering, select this one instead. All right, frame rendering 2, which will be sometimes force AFR2 if you're gonna use some other drivers. This is the June 2023 drivers, so I showed you just in case how to set the profile, and pretty much this is how you want to do it. Go ahead and smash that pause button, and it's going to utilize the SLI. And if you're going to use the two GTX 1080 Ti's, it's going to perfectly utilize an Intel Gen 9 at 100% under the SLI, under the 8K resolution and above 8K for sure, 100%, 99, 100% per video card per GPU. If you're going to use the GTX 1080 Ti or Titan X Pascal GPU architecture or Titan X Maxwell GPU architecture, will be just perfect under the 8K UHD, enough of video RAM for sure. And even Titan X Maxwell and Titan X Pascal GPU architecture will be more than enough on the 16K video resolution as well, due that our video RAM utilization will be a little bit above 12,000 megabytes. Go ahead and check out my video and video comments below. A 16K video resolution running on 2 Titan RTX video cards and SLI. So you can run 4 Titan X Maxwell GPU architecture or 4 Titan X Pascal GPU architecture and actually demonstrate equal performance to 2 Titan RTX video cards and SLI, or even a little bit faster when we're talking 4 Titan X Pascal GPU architecture. And you're not gonna run out of the video RAM, at least at the beginning of the game. But when there's going to be a lot of fighting, a lot of enemies, there is a possibility you're going to overrun your video RAM under the Titan X Maxwell GPU architecture or Titan X Pascal GPU architecture. All right. So I did the ADA 64 benchmark GPU, 2 GPUs versus the CPU. Some other benchmark. I'm running crazy fast DDR4 today. It's not fast in terms of the frequency. It's running 3200 megahertz, but originally it's DDR4 5000 megahertz. But I'm running crazy aggressive timing, CL11 instead of CL16, CL14, not even CL12, CL11. Very crazy aggressive timing, and it's unbelievable performance. So I'm running only 8 physical cores, hyper-threading technology disabled under the ASUS Z390 chipset Maximus 11 here on motherboard. So when we're talking the performance in PC gaming, we're in 2023, even in 2025, you're looking at the single thread performance. The higher number of single thread performance, the better FPS will be in the game. When we're talking when every single core, every single thread utilized at 100%, you're looking then under CPU Z benchmarks CPU multi-thread performance, such as 3ds Max application, 3D rendering application, Cinema 4D, or Blender. For the 3D rendering, but not in real time. Alright, let me real quick go ahead and show you comparing to all kind of different CPUs. Go ahead and smash that pause button, but I'm going to show you to you that I'm going to dominate AMD 3000 series flagship, and I'm going to dominate. By the way, this is the CPU that I was talking about. You can run this Intel i9 7980XE, and you can have 2 Gen 3 PCI Express Gen 3 slots at 16x per slot, and using those 2 Titan RTXs per slot at 16x Gen 3 PCI Express speed. But as again, it doesn't matter for Titan RTX, and this CPU will be slower than my Intel Gen 9. Keep that in mind. You can use 9980XE, but still going to be slower than i9 9900K at 5.2 gigahertz. All right. In particular of PC gaming, but not 3D rendering. 3D rendering, 9980XE will dominate of my i9 9900K. Alright, especially when hyper-threading technology is shut down. Check it out. I'm dominating Intel Gen 10, even clock per clock, at having the higher instruction per clock. But just because my Intel Gen 9 is overclocked, my 9900K, I'm dominating by a little bit in terms of the single thread performance in PC games, as again, by about 40 points. Alright. Let me demonstrate some more CPUs for you. Go ahead and smash that pause button. Maybe if you're building computers from the used parts, which is the best way to build computers, you're going to find your CPU and you're going to see what's going on. This is the same CPU that I'm running right now, 9900KF, but I'm running 99K, which is pretty much the same deal. KF without the display, HDMI port, support by the CPU, integrated GPU. And as you can see, I'm dominating almost by 100 points. So this is how fast I am, while overclocking my CPU from 3.6 all the way to 5.2 in home safe environment. And as again on the background, this is the computer that I'm running. It's water cooled by the Corsair H150i Pro with 360mm radiator and 3 Corsair fans. On top of it, 200mm Cooler Master fan, and it's set on liquid metal thermal compound paste by Thermal Grizzly, as well as my GPUs and video cards set on liquid metal thermal compound paste by Thermal Grizzly, and video RAM set on the video card set on the Arctic Silver thermal compound pads. Right. Just cool it down a little bit, but it didn't help that much, especially when you're running SLI. When you're running single video card, it helps lower temperature by 5 Celsius, but when it's SLI, it's still going to thermal throttle, because the closest video card to the CPU will be thermal throttling, because there is no space between them to breathe, and it's breathing the hot air. Alright. So go ahead and please watch this video at least in 4K UHD video resolution, switch in your YouTube player, but the best visual experience will be 8K UHD. Go ahead and do that. Alright, so it's demonstrated for you all kind of different CPUs, so you have the clue. Let me show you this again inside of the system, but you saw it at the left top corner. This is just as additional fact for the naysayers. 8x per PCI Express Gen 3 per slot, as you can see, but as again, it doesn't matter for the Turing GPU architecture Titan RTX video card. It might be matter, especially when we're talking PCI Express Gen 3 for the RTX 4090 video card, because it's required Gen 4 PCI Express. And if you're running Gen 3, you most likely should run at 16x to push that high bandwidth. But for the Turing GPU architecture, such as RTX 2000 series video cards or flagship of the RTX 2000 series video cards, such as gaming video card Titan RTX, no problem, guys. At 8x PCI Express Gen 3, right? As you can see, this memory was Corsair DDR4 5000 MHz CL18, but unstable on this motherboard because it's not Samsung B chips. In DDR4, they go above 4200 MHz easy, but this is the Micron chips, and Micron chips doesn't like the frequency when it comes to DDR4, but loves the latency. Lower latency is the key, is faster, and this is how I utilize CL11, not CL16, not CL14, not CL12, CL11. 1600 MHz, which is times 2, 3200 MHz as output frequency on DDR4, 3200 MHz, CL11, 1T command, the best, guys. Cache frequency was running 48 multiplier, which is 4800 MHz or 4.8 GHz dual channel, 128 bit, but 4 sticks, 8 GB, the best scenario for DDR4 in dual channel running 4 sticks. No matter how cheap your memory is, single bank, dual bank, you're going to demonstrate the maximum bandwidth that your CPU supports. In my case, I'm running a little bit faster than that because I'm running CL11. So this CPU bandwidth is 42,000 megabytes per second read write, and I'm pushing almost 50,000 megabytes per second because I overclock it to 3200 megahertz and CL11 latency delay 1T command, very crucial. All right, so two Titan RTXs, of course, for those naysayers, and running completely stock. Is again, if you're gonna overclock it, but you're gonna at least waste 150 bucks, and if you're gonna overclock them and set them on water, both video cards, then you're gonna at least waste $300. But you don't need to set both on water. The first video card is set on water on some gonna get a homemade AAO. Buy the extension for 29 bucks on Amazon, and some dual radiator like 240 millimeter Corsair water cooler for CPU, attach on GPU. You will be Gucci, guys, and you're gonna cool down, but you're gonna achieve 10% higher performance. Not that biggie, about maximum 5 FPS. So whatever FPS I was using through the Nvidia ShadowPlay, it's gonna compensate it even when you're gonna record it, or it's going to be even 10 FPS higher without the recording. But as again, doesn't matter. You better invest this money while selling these Titans towards the better newer generation of the video cards, and single video cards at newer generation higher performance will be always better than two video cards in SLI. But Titan RTX is again is the latest dinosaurs, is the latest mammoth. The latest will be RTX 3090 Ti, and after that point is going to be no SLI support, because as again, games will be released on DirectX 12 API, and SLI supports only DirectX 9, DirectX 10, and DirectX 11 APIs, and DirectX 12 API only supporting multiple GPUs. That is not Nvidia SLI. Alright, everything was demonstrated for you guys. As again, today is June 24th, but already 25th. It's night time. It's almost 1 a.m. Don't forget to go ahead and smash that like button. A lot of time, money, energy is invested, and support me, guys. Visit my sponsors, positive comments, check out the video comments for more related videos in 4K, 5K, 6K, 7K, 8K, 10K, 12K, and even 16K video resolution on two Titan RTX video cards and SLI, on a single RTX Titan RTX video card on the same computer. And also I'm going to test on all kind of different PC systems, all kind of different video cards, including the mobile systems as well, such as iOS devices and Android devices in the future. So this is going to be a benchmark. Go ahead and check it out, because this was my benchmark since I was running 4 Titan X Maxwell GPU architecture and SLI all the way back in 2016 when I did the first 16K video resolution for Diablo III PC game. Go ahead, guys, and check it out. As again, I'm going to include in video comments. Smash that like button, support me, share it with your friends. As again, my name is UHDking, or I play 4K, aka I play 8K, aka I play 16K. You know exactly why. UHDking. Have a good morning, good day, good afternoon. Till the next time.